Well, good day, everybody. This is Chris with The Ancient Scholar. I hope this video finds you doing well. So in this video, what I want to do in an attempt to establish some sort of normalcy in my channel and to try to pivot away from talking about COVID so much, because I don't really feel I have a whole lot, and I never really did have a whole lot to offer in the COVID conversation other than just to kind of look at what the contemporary data is and then attempt to communicate the conclusions based on that to some varying degrees of effectiveness throughout the last couple of years. And so I kind of want to go old school, and I want to redux video series that I've done in the past, particular one series where I was in graduate school. I studied pharmaceutical sciences, specifically clinical toxicology, in graduate school, and I did a playlist on various psychoactive substances. And in fact, it was my studies in graduate school that opened the doors of perception, shall we say, into more allegedly personal experiences with substances that may or may not have allowed me to, or may or may not have facilitated some profound growth, shall we say, allegedly, of course. Be that as it may, I want to redux those a little bit, and I want to talk about a substance that I really neglected, and it's really a fascinating substance. I have absolutely no personal experience, alleged personal experience with this substance, but I still find it to be fascinating nonetheless. And this substance actually comes from a plant known as Salvia Divinorum. I believe it means sage of the diviners. What a cool fucking name, right? I believe that's a Latin term, sage of the diviners. It goes by some other names as well, but Salvia is what most of us would understand when we hear that term. And specifically, there's a substance called Salvinorin A that comes from that particular plant that has psychoactive properties. It's not incredibly well researched, so what I'm going to be talking about is just kind of a high-level overview of the substance. But it tends to be either smoked, or I hear that sometimes it's used, it's ingested in a tea, but I think I'm most familiar with it being smoked, the dried components of the plant. So what I want to do is I want to talk just a little bit about the chemistry, because I find the chemical structure is rather interesting when it comes to Salvinorin A. So when we talk about psychedelics or substances that are more classically psychedelic, so things, the classic psychedelics really are chemical derivatives or analogs of 5-hydroxytryptamine or serotonin, and many of these fall under a large category of molecules known as alkaloids. And an alkaloid is a big group of organic compounds. Organic in this context is any molecule that uses carbon as its backbone, essentially. And specifically, these tend to be organic compounds that often come from amino acids. Tyrosine, for example, is a big one. L-tryptophan, right, when we're talking about serotonin. And so the classic example, or an example of a kind of a classic psychedelic substance is something like this. So this is a molecule, maybe we'll do that there. So this is a molecule of something called NN-DMT, or NN-dimethyltryptamine. So this is very chemically very similar to serotonin, which is 5-hydroxytryptamine, right? And so this is a good example of an alkaloid. So what you have here in this particular case, and a lot of molecules like this that fall under the category of what we call indole alkylamines, so DMT and psilocybin would both fall under this category, and those are very good examples of kind of classic psychedelics. And so what you have here is you have this indole ring here, and you have an aromatic ring right here These are also known as benzene rings attached to a pyrrole ring, so 6 carbon, 5 carbon, a pyrrole ring, and you've got, of course, this nitrogen here. And then you've got a little carbon bridge that's attached to a nitrogen here, and you've got these 2 little methyl groups, functional groups, coming off of this nitrogen here. And that's where the term N,N-dimethyltryptamine comes from, right? So you've got your indole ring here attached to nitrogen, and then you've got 1 methyl group here, 1 methyl group here, right? So N, 2 coming off the nitrogen, dimethyltryptamine, right? So that's kind of what we see here. So this is a classic example of the chemical structure of your more classical psychedelics. Some of the other types of molecules that have psychedelic properties are substances that fall under the category of what's known as a phenethylamine, which, unlike the indole alkylamines, come from a different amino acid. Let me see if I can show you an example of a phenethylamine, which come from phenylalanine. So here's an example I have. So this is an example of another agent that has psychoactive properties. This is actually a molecule of mescaline. So you can see it still has some similarity. You've got the aromatic ring here, right? And these are oxygen atoms, and these are methyl groups. But you can see that, like substances that come from many amino acids, you have this nitrogen here, right? Now this is not an NH2, right, like you'd see here, but in both cases, an example of a phenethylamine versus an indole alkylamine, you have these nitrogens that come from amino acids in both cases. Now, when it comes to, and many substances are like this, a lot of the opioids as well, like morphine, have a multicyclic structure with nitrogens. The interesting thing about Salvia, Salvinorum A, is it belongs to a category of substances known as terpenes. Think of like turpentine, different saps and oils like that. And the terpenes, unlike these particular molecules here, have aromatic structure to them, and in fact they have several aromatic rings. I think Salvinorum A, it actually is too large of a molecule. I don't have enough of these to make an example of a Salvinorum A molecule, but it has like 3 aromatic rings and another, I believe, an oxygen containing ring. So it's fairly complicated. It still has aromatic rings, but unlike these specific molecules here, the terpenes do not have the nitrogens that come from amino acids like you see with your more classical psychoactive agents, the alkylamines and the phenethylamines. Different amino acids, but you're still getting the amine from the term ammonia, and ammonia is a nitrogen and 3 hydrogens, NH3. You got this, but you don't have that nitrogen being donated or coming from an amino acid in the terpenes. And so chemically, it's very different, very distinct as a psychoactive agent from the more classical agents, the phenethylamines and the indole alkylamines. All right, so I know I've spent a lot of time talking about the basic chemical structure of these molecules, but I just find it fascinating and very interesting. So let's talk about Salvinorum A and kind of how it does, because its mechanism of action, as you might imagine, chemically it's a little different, but its mechanism of action is profoundly different from many of, really from all of the more classical psychoactive agents. So your classical psychoactive agents, particularly your indole alkylamines, their major mechanism of action, this is is a necessary but insufficient, right? So it's more complicated than this, but the 30,000 foot view is that these molecules agonize or activate a very special kind of receptor in the central nervous system known as a 5-HT2A. 5-HT just means 5-hydroxytryptamine. That's just a chemical name of serotonin. So these they act a lot like serotonin, and they attach to and they agonize the 5-HT2A, the serotonin 2A receptors. And in the central nervous system, I got my brain here, you have a lot of serotonin 2A receptors located deep in the cerebral cortex. So the cortex is kind of the outer part of the brain. In evolutionary terms, this is the newer part. So it's the outer convoluted part. And this is where you have a lot of your higher order functions, cognition here, movement and sensation here, visual processing back here. And then the cortex sits on top of the deeper structures like the midbrain and the lower parts of the brain, the limbic system and whatnot. And so deep in the cortex, deep in this outer part, is where you have high concentrations of these serotonin 2A or 5-HT2A receptors. And so these molecules attach to activate those receptors and actually increase activity within the cortex, increase cross communication, and you get novel patterns of brain activity essentially emerging. And again, I'm simplifying this to the point of almost not being accurate in any way, shape, or form, but essentially, big picture view, that's kind of what's going on. And reality, it's we actually haven't elucidated everything to a great degree, but that's kind of the big picture. Now, that is very different when talking about Salvinorum A. So when you smoke Salvinorum A, it does go into the central nervous system, but instead it agonizes, or it interacts, shall we say, with a completely different kind of receptor. It actually interacts to something called a Kappa receptor, and a Kappa receptor is actually a type of opioid receptor. So it is a receptor that gets activated by opioids. And there are three classical, what we call the classic opioid receptors. You got your mu, kappa, and delta receptors. For most pharmacological purposes, it is the mu receptor that everybody talks about, right? That's where you get, you've got mu receptors in your spinal cord and in your brain, and when those get activated, you get modulating of pain signals, you get euphoria. You can get respiratory depression if those receptors are agonized in sufficient amounts in or around the respiratory center, in the respiratory centers in the pons and the medulla. And so that's kind of where you get some of the classic findings that we see with opioids. And so we kind of don't really talk so much about, say, the kappa receptors. And so what I want to do is I just want to talk a little bit about the kappa receptors. So like I said, Salvinorum A binds to and activates or agonizes the kappa receptor. And what does that do in the brain? Well, in the brain, in the central nervous system, you have a structure that is known as the colostrum. And the colostrum is, think of it as kind of a structure that helps modulate activity, sort of similar like the thalamus, where you talk about the thalamus and it acts as a relay station. Is something somewhat analogous to that. And the colostrum is actually located deeper in the brain, so it's actually not in the cerebral cortex, but rather it's located inferior to this structure here. So this structure here is known as the Corpus Callosum, and it's essentially a connection that allows for communication between the right and left hemispheres of the brain. It's one of the major, there are a couple of, or a few, but it is one of the major ways that the right and left hemispheres of the cortex, the cerebral cortex, can cross-communicate. Now, just inferior to that, there is a structure known as the colostrum. And let's talk about what the colostrum does first of all. So, like I said, it kind of it helps regulate, if you will, cortical activity or activity up in the upper part of the brain. That's essentially what it does, right? It kind of it kind of helps conduct things a little bit, kind of helps with the signal to noise ratio, so to speak, right? It kind of helps the cerebral cortex, kind of helps filter out the noise and kind of helps things not go so crazy, right? You get a lot of stuff going on in there, and it kind of helps regulate, modulate the activity, so it's just not complete madness going on up there. So when you bind to those kappa receptors, what that does is that actually suppresses neurons within that structure, right? And that then prevents the colostrum from regulating activity up here. And so what happens is, because you can't kind of suppress and regulate, modulate the activity, novel patterns of activity will start to emerge in the cortex, and that is possibly where the psychoactive effects of Salvinorum A derive from. So it's a little different than the classical psychoactive agents, which kind of directly activate the cerebral cortex through the 5-HT2A receptors. Essentially what smoking or ingesting salvia does is it suppresses parts of the brain that kind of keep activity in the cerebral cortex in check in some sense, and then that allows novel activity to emerge. And that is kind of the thinking behind where the psychoactive effects of Salvinorum A in particular come from. There are actually other substances located, there are other substances in Salvia Divinorum, and so I'm just kind of specifically talking about Salvinorum A, but it's, it's a complex interplay of various different molecules. So that's kind of what goes on there. Now, as far as from a pharmacokinetic standpoint, and even a pharmacodynamic standpoint, I don't have a whole lot to say because we just really haven't studied this in any great detail. As I understand, the toxicity isn't well known, but it doesn't look like salvia is, from a physical standpoint, very toxic. Now, when it comes to the psychological aspect, you could expect that depending on the person, the setting, individual circumstances, the psychological aspect of this abnormal or non-ordinary state of consciousness that's produced can be potentially distressing. But interestingly enough, Salvinorum A, the effects of it are very short-lived, on the order of minutes. So it's very similar to smoking dimethyltryptamine, or vaporizing, smoking essentially, but you got little particles that you're inhaling. It's similar to that, on the same order of several minutes. So it's a very short-lived experience for the most part. I don't know about ingestion, and I don't know a whole lot about the if there's a substantial first-pass metabolism. So if you drink tea with Salvinorum A, is there going to be, is it going to go into the liver? Is there going to be substantial first-pass metabolism? And there are different active and inactive metabolites that come into play. I'm not sure. Is it something like marijuana, cannabinoids, where when you do edibles, there are different metabolites that are produced through first pass. You get absorption into the gut, and then that goes to the liver. Enzymes then prior to that going into your central circulation and going into your brain, there's metabolism, and so you have different metabolites that are produced, and so the edible experience can be very different. I'm not entirely sure if that is a similar situation with Salvia Divinorum. there very well may be some other metabolites. Again, this isn't like super well studied, so I can't really comment on in detail on the pharmacokinetics and pharmacodynamics and the enzyme systems involved in the biotransformation of these molecules, but I suspect with the rather short duration of action when it comes to smoking it, there are probably a lot of plasma enzymes and hydrolytic enzymes and whatnot that are probably involved even when ingested. That would be my guess. But either way, that's really fascinating to me that you can have a psychoactive substance work through an entirely different receptor system, and you can have non-ordinary states of consciousness. And as far as the subjective experience, I don't have anything to say. I've read some reports, and it does sound like it can produce a very interesting experience, fairly similar to what happens with people that have breakthrough experience with DMT. Not exactly, but that same kind of just discombobulation, loss of self, loss of ego, fear, terror, things like that. It does seem like there are large numbers of people that have had very difficult experiences with this. Maybe not unlike 5-MeO-DMT or 5-methoxy-DMT, which is essentially it's a modification of the DMT, and you have a methoxy, a methyl group attached to an oxygen, and it produces very interesting effects. I can allegedly say that it is not at all like the experience with DMT. It's actually I would allegedly say I'm not a fan, but I've heard or seen trip reports of salvia trip reports that are more on the lines of that, where it can be a very harrowing, difficult experience. So that's really all I have as far as salvia. This is an incredibly long video, and there's a lot of buildup and a lot of foundational stuff, but I just get a kick out of talking about the chemistry a little bit, and I think it's really neat to be able to compare and contrast from a chemical perspective, at least from a basic understanding of the differences, and maybe just appreciate the differences in terminology, like what is an alkaloid, what is a terpene, right? And kind of where these come from, and the amino acids that make up some of these. I don't know. I just find it really interesting, and unfortunately, it's just not something I get to do as a part of my day-to-day job, and so I'm really excited to take a little bit of time to go back to something that I find really interesting. All right, so I hope you all enjoyed this video. I hope you found it interesting, something a little different. And that's really all I have for today. So have a great weekend, everybody, and we'll see you in the next video.